Today we'll be doing the sum from 1 to infinity of cosine of k pi over 4 divided by k. And to start off, we will notice that the natural log of 1 plus t is the sum from 1 to infinity, negative 1 to the k minus 1, t to the k over k. And we're going to let t equal negative e to the I theta. So we have the natural log of 1 minus e to the I theta is the sum from 1 to infinity, negative 1 to the k minus 1, negative e to the I theta to the k over k. So natural log of 1 minus e to the I theta is the sum from 1 to infinity, negative 1 to the k times negative 1. We can rewrite this as negative 1 to the k e to the I k theta divided by k. So these negative 1 to the k's multiply to 1, bring down the negative, we have minus the sum from 1 to infinity of e to the I k theta divided by k. So we have the natural log of 1 minus e to the I theta. We have minus the sum from 1 to infinity, e to the I k theta can be rewritten as the cosine of k theta plus I times the sine of k theta, and it's going to be divided by k. But we could split this up into natural log of 1 minus e to the I theta equals negative the sum from 1 to infinity cosine of k theta divided by k, and minus I times the sum from 1 to infinity of the sine of k theta divided by k. And then from here, I'm going to take the real part on both sides. So you have the real part of the natural log of 1 minus e to the I theta is the real part of negative the sum from 1 to infinity cosine of k theta over k minus I times the sum from 1 to infinity sine of k theta over k. So we have the real part of the natural log of 1 minus e to the I theta is, the real part of this would be negative the sum from 1 to infinity cosine of k theta over k. We could put the negative to the other side. And now we have negative the real part. We could decompose the natural log of 1 minus e to the I theta as the natural log of the modulus of 1 minus e to the I theta plus I times the principal argument of 1 minus e to the I theta is the sum from 1 to infinity cosine of k theta over k. But we're interested in the real part of this, so we're just going to have a negative the natural log of the modulus of 1 minus e to the I theta is equal to the sum from 1 to infinity of the cosine of k theta over k. So we have sum from 1 to infinity cosine of k theta over k is negative the natural log of the modulus of 1 minus cosine theta minus I times the sine of theta. So we're going to have a negative the natural log. Taking the modulus, we have the square root of 1 minus the cosine theta squared plus negative sine theta squared, negative the natural log of the square root of 1 minus 2 cosine theta plus cosine squared theta and plus sine squared theta. But we know the cosine squared plus sine squared is 1. We have a 1 plus 1, which is 2. So we can rewrite this as negative 1/2 the natural log of 2 minus 2 times the cosine of theta. So we have sum from 1 to infinity, cosine of k theta divided by k is negative 1/2 the natural log of 2 minus 2 cosine theta. So now all that's left is to let theta equal pi over 4. So this means that the sum from 1 to infinity of the cosine of k pi over 4 over k is negative 1/2 the natural log of 2 minus 2 cosine of pi over 4, which is negative 1/2 the natural log of 2 minus 2 times the cosine of pi over 4 is the square root of 2 over 2. So these 2's are gone, and so we're left with negative 1/2 the natural log of 2 minus the square root of 2. So this is the result. Thank you very much for watching.